Welcome to AKN Sprint Education. Myself Naveen, I am the Maths Mentor. Today's session, let us see the key concepts related to the chapter sets. In mathematics, items together that have a common characteristics so that they can be treated the collection as a single object. See here, items together that have a common characteristics so that they can be treated the collection as single object. We specified a common property among things and then we gathered up all the things which have this common property. Then searched for more properties and tried to elect these properties to propose new statements. That is called set. A set is a collection of things that have something in common or follow a rule. The things in the set are called elements. Common rule decides the elements of the set. Such sets are well-defined collection. In other words, a well-defined collection of distinct objects is called a set. What is the definition of set? A well-defined collection of distinct object is called a set. Set notation uses braces with elements separated by commas. Objects, elements and members of a set are synonyms of words. Either we call it as objects or elements or members of a set. Sets are usually denoted by the capital letters like A, B, C, X, Y, Z, etc. An object belonging to a set is known as a member or element or individual of the set. The elements of a set are represented by small case letters, that is A, B, C and so on, small x, small y, small z, etc. If B is an element of set A, then we say that B belongs to A. The word belongs to is denoted by the Greek symbol belongs to. Thus, in notation form, B belongs to A written as B belongs to A and C does not belongs to A is written as C does not belongs to A. Now, representation of set. Sets are usually represented by the following two methods. First one is roster form or also we call it as tabular form. Second one, set builder form or also we call it as rule method. In roster form, all the elements of set are written separated by commas within curly brackets. For example, the set of all natural numbers less than 5 is represented as n equal to set of 1, 2, 3, 4. Second example, the set of all letters in the word January is represented as B equal to A, J, N, U, R, U, Y. Here the most important note is in roster form, the order in which the elements are listed is immaterial. Thus, the set of digits in the Ramanujan number is 7219. In between we have commas. Here 7219 are called elements or objects or members of the set. While writing the elements of a set in roster form, an element is not repeated. For example, the set of letters forming the word school is S, C, H, O, L and it is not written as S, C, H, O, L because if at all any letter is repeating twice, we need to write only once. Therefore, a set contains distinct elements. Okay. The next one is set builder form. In this method, a set is described by using a representative and stating the property or properties which the elements of the set satisfy through the representative. For example, you see set of all natural numbers less than 5. Here the property is what? They are natural numbers less than 5. So A equal to x such that x belongs to n and x must be less than 5. Second one, set of vowels in the English alphabet. So the property is here, they are the vowels of English alphabet. So that is x such that x is a vowel in the English alphabet. It may be observed that we describe the set by using symbol x or y or z etc. are elements of the sets. Now coming to types of set. The first one is empty set. A set which does not contain any element is called an empty set. Also we call it as null set or a void set. Empty set is denoted by pi or pi. For example, you see x says that x is a natural number smaller than 1. Is there any natural number smaller than 1? No. So which does not contain any element, that set is said to be an empty set. For example, x says that x is a man living on the moon. Is there any man living on the moon? There is no man at all. Hence it is a empty set. For example, set b equal to x square minus 2 equal to 0. X is a rational number. Suppose if you take any rational number. So 1 square, 2 square or 3 square. If you take any rational number that such that x square minus 2 is not equal to 0. So such set is said to be an empty set. Another name for empty set is null set or void set, and the symbol is denoted by pi, phi, pi. Okay. So the most important point is here, pi and element 0 are two different sets. Element 0 is a set containing a single element, while this open bracket is a null set. Now coming to second one is singleton set. A set consisting of a single element is called a singleton set. A set consisting of a single element is called a singleton set. You see here in the diagram only one element is there. Here also only one boy is there. So here 0 and -7 are singleton sets. Okay. Now coming to finite set. The name itself, a set which is possible to count. I mean number of elements in the set are countable. That set is called as an finite set. If you see the set 3, 4, 5, 6, which is a finite set because number of elements are 1, 2, 3, 4. So such set is said to be a finite set. The set of days in a week. How many days in a week? We have 7 days in a week. It is countable. So such set is said to be a finite set. And one more important point is an empty set which does not contain any element is also a finite set. Now coming to infinite set, a set whose elements cannot be listed. That type of set is called a finite set. For example, x says that x is an even number. We have infinite number of elements, right? X says that x is a multiple of 7, 7, 14, 21 and so on. The set of all points in a plane and so on. That set is called as infinite set. A set is infinite if it is not finite. Now coming to equal set. Two sets are said to be equal if they have exactly the same elements. You can observe here in these two sets. In set A we have watch, ring and flower. In set B also we have watch, ring, flower. Okay, the elements are same. If the two sets are having the same elements, such sets are said to be equal sets. Now coming to cardinal number. The number of elements in a set is called the cardinal number of the set. If you observe here set A, it consists of elements 1, 2, 4. How many number of elements are there in set A? 1, 2, 3. So it is represented by n of A. I mean number of elements in set A is 1, 2, 3. We have to write 3. The next one is universal set. A set which consists of all the sets under consideration. Right? So see here discussion is called the universal set. A set containing all objects or elements of which all other sets are subsets. It is usually denoted by mu or u. The universal set is usually represented by rectangles. The set of real numbers is a universal set for number theory. Here R is universal set. R is called universal set, which includes natural numbers, whole numbers, integers and rational numbers. If we want to study various group of people of our state, universal set is the set of all peoples in Andhra Pradesh or Telangana. Subset. In every element of first set A is also an element of second set B, then set A is called a subset of second set B. What is that? Every element of first set A is also an element of second set B. Then the first set is said to be a subset of second set B. It is represented by A subset B. Okay, A subset B. For example, you see set A equal to 2, 4, 6, 8. Set B equal to 1, 2, 3, 4, 5, 6, 7, 8. As the elements of A, 2, 4, 6, 8 also there in set B. Then we say that set A is subset of set B. Okay. Now empty set is a subset of every set, which is the most important point. Empty set is a subset of every set. And the second important point is every set is a subset of itself. Every set is a subset of itself. Consider A and B are two sets. If A is subset of B and B is subset of A, then we say that set A and set B are equal, right? Now, a set does not change if one or more elements of the set are repeated. If A is subset of B and B is subset of C, then we say that A is subset of C. Okay. Now coming to Venn diagram. Venn Euler diagram or simply Venn diagram is a way of representing the relationship between sets. These diagrams consist of rectangles and closed curves, usually circles. Consist of rectangles and closed curves, usually circles. Consider that mu equal to 1, 2, 3, 4 and so on 10 is the universal set, of which A equal to 2, 4, 6, 8, 10 is a subset. I mean A is a subset of universal set. Then the Venn diagram is as follows, right? Now coming to basic operation on sets. In sets, we define the operation of union, intersection and difference of sets. Coming to union of sets, the union of two or more sets is the set of all those elements which are either individual or both in common. In symbolic form, union of two sets A and B is written as A cup of B and usually read it as A union B. Set builder form of A union B is A union B equal to X such that X belongs to A or X belongs to B. The union of sets can be represented by a Venn diagram. See, this is A and this is B. This everything is union under universal set. Okay, we need to shade this whole portion. It comes under A union B. It is evident from the definition that A is subset of A union B and B is also subset of A union B. Roster form of union sets. Let A equal to A E I O U and B equal to A I U. Then what is A union B? A E I O U union A I U. See here, element A is common, so we need to write at once. E is only once. I is repeating two times, we should write only once. O one time, U one time. So what is A union B? A union B equal to A E I O U, right? That is union. Now coming to intersection of two sets. The intersection of two sets A and B is the set of all those elements which belongs to both A and B. I mean common elements. We denote intersection by A cap B. We read A cap B as A intersection B. Symbolically we write A intersection B equal to X such that X belongs to A and X belongs to B. What about here? X such that union is X such that X belongs to A or X belongs to B. This is X such that X belongs to A and X belongs to B. The intersection of A and B can be illustrated in the Venn diagram as shown in the shaded portion of the adjacent figure. So here only A intersection means this part. Only this part is intersection, right? This is the second operation. Now the intersection of A and B can be illustrated in the roster form. A equal to 5, 6, 7, 8, B equal to 7, 8, 9, 10, then A intersection B. What is the common element here? 7, 7, 8, 8. They are the common elements. Therefore A intersection B equal to 7, 8. Now disjoint set. Consider A and B are two finite sets. If there is no common element in both set A and B, such set is known as disjoint set. Or else A intersection B equal to 5. Two sets are said to be disjoint sets if they have no common elements. That is, the intersection of two sets is a null set. They are disjoint sets. You see, if there is no elements in common in both the sets, this can be represented by means of Venn diagram as shown in the adjacent figure. So there is no common, so we need to draw separately set A and set B in the universal set. Now coming to difference of sets. The difference of sets A and B is the set of elements which belongs to A but not belong to B. It belongs to A but not belongs to B. We denote the difference of A and B by A minus B or simply A minus B. Set builder form of A minus B is X such that X belongs to A and X does not belongs to B. So Venn diagram of A minus B is only this part, only A but not B. Venn diagram of B minus A is only B but not A, right? A minus B is not equal to B minus A. So fundamental theorem on sets. If A and B are any two sets, then the most important formula n of A union B equal to n of A plus n of B minus n of A intersection B. So n of A union B is the number of elements in the set A union B, also called cardinal number of A union B. N of A is the number of elements in set A, also called cardinal number of A. N of B is the number of elements in the set B, are also called as cardinal number of B. So these are the key concepts in the chapter sets. Once if you know this all the key concept, we can do all the exercises very easily. So students, don't forget to hit subscribe button, like it and share it with your friend children. Thank you.